Hi guys, welcome to the presentation. We're drawing exponential curves. This particular example, we've got a bit of a tricky one. We've got y equals 2 to the power of a negative exponent. Now what does that mean? If it's got a negative exponent, it's going to probably be the opposite or mirror effect of the positive one. But we're about to see, because we're going to put it in a table of values. I'm going to show you how to substitute in this one, because it can be tricky when you've got a negative and another negative. So let's get started. Let's plot all the points in here and then plot them along here and see what that curve looks like. So let's have a look at the first one. We've got an x value of negative 2. We're going to substitute it right in there. Let's see what we get. So that will mean we have 2 to the power of negative, and then we already have another negative of negative 2. So there's two negatives, meaning it's going to be 2 to the power of positive 2. So 2 to the power of 2 is simply 4. So let's put that in. Okay, the next one's interesting. We got 2 to the power of negative 0. A negative 0, 2 to the power of negative 0, just means 0, which means we always get 1. Anything to the power of 0 is 1. Let's put that in there. The next one's easy. It's 2 to the power of negative 1. To the power of negative 1, that's going to give us a value of 1/2. And finally, we have 2 to the power of negative 2. That's going to be 1/4. All we have to do now is plot the points. So let's put them in black. So the first point is 2, 1/4. 2 and 1/4. So here's our 2. We're only going to go up 1/4. If 1's there, so 1/4 should be about there. So it should be approximately there. Okay, the next point is 1.5. So we have 1, x value of 1, and 1/2 is approximately there. Let's put it right about there. Then we've got 0, 1. It always cuts through there, so it's going to go through there. And then finally, let's go all the way out to negative 2 and 4. So we go negative 2 right over here, all the way up to 4. That should be right about there. So there are our points. As you can see, it's going out this way and rising rapidly. And of course, the x-axis is an asymptote. As we get larger numbers along the x-axis, the curve actually gets closer and closer to the x-axis asymptote, but it never actually touches. So let's join the dots. I'm going to put a big black bold curve. So let's put these in here. Goes there. Through that point, goes through 1, goes through 1/2, goes through 2. There's our curve right over there. Well, there you have it.